Hi everyone, this is Mrs. Jackson. This is Chapter 4, Section 1, Part 3. In this video, we are going to talk about how to find the quotient of rational expressions. The way we do that is basically the same method as we would find the quotient of fractions. And the way we do that is we take that first fraction, which is the dividend, and let me label that here, the dividend. And we multiply that by the reciprocal of the second fraction. And I'll just call the second fraction here the divisor. Maybe I'll label it below here. And just as in the case of multiplying rational expressions, we're always going to simplify the result. Okay, so first, let's take a look at just pure rational numbers here. I have 96 fifths divided by 18 sixtieths. So if we want to look at that, the first thing I'm going to start to do is break down some of the numbers so I can simplify easier. 96, I think of 12 times 8 over 5. And then I am going to change this division to multiplication of the reciprocal of the divisor, and so I've got 60 over 18ths. And then I'm going to keep simplifying here. So I've got so far 12 times 8, and for 60, I guess I think of 6 times 10, and 18, I think of 6 times 3. So you don't have to go all the way down to prime factorization, just enough to see where you can simplify. So I automatically or immediately see that my 6 divided by 6 reduces to 1, and 10 divided by 5 is 2, so I'm going to cross that out and just replace that with a 2. And I've got 12 divided by 3 is 4. And so what I have left is nothing in my denominator. I have 4 times 8, which is 32, times 2, which is 64. All right, let's take a look at another example here. This time I've got 64 thirds being divided by a whole number, 12. And so we're going to follow the same process here. 64, I think of 8 times 8, divided by 3. And I'm going to change that division to multiplication of 1 over the reciprocal, so I think maybe 4 times 3. And so I have 8 times 8 in the numerator. I have 3 times 4 times 3 in the denominator, and I'm going to start to simplify. I've got 8 divided by 4 simplifies to 2, and that's about all I can do. So up on the numerator, I have 16. In the denominator, I have 9, so 16 ninths. Before we look at expressions, I want to take a quick look at some of the common student misconceptions. The first number one, or I should say errors, the first one is forgetting to take the reciprocal. So do note that 1/2, for example, divided by 3/4 does not equal 1/2 times 3/4. And you could prove that to yourself pretty easily. 1/2 times 4/3 is going to give me 2/3, and that certainly does not equal 3/8. So that's a common error. The second common error, or point of confusion, I would say, is when the fractions are listed vertically. For example, 1/2 divided by 3/4. So again, that numerator here is the dividend, and the denominator is the divisor. So to rewrite that, I have 1/2 divided by 3/4 if I wanted to rewrite that horizontally. Okay, so more importantly, how do we apply these concepts to finding the quotient of rational expressions? In my first expression, I have 1 over x squared plus 9x. That's being divided by a rational expression, 6 minus x over 3x squared minus 18x. So we kind of take this one step at a time. I'm going to start out with simplifying this first one. I can see in the denominator an x can be factored out. So I'll have x plus 9 here. And I'm going to go ahead and keep division for a moment until we can simplify this out. The numerator, I have 6 minus x, and in this denominator, I can factor out a 3x. And that would leave me x minus 6 left. Now let's go ahead and change our division into multiplication. I'm going to just point that out here so that people can see it. And then I'm going to take the reciprocal of the divisor. So the 3x times x minus 6 is now in the numerator, and the 6 minus x is now in the denominator. And now I'm going to get everything together in the numerator, kind of written out as factors. So I have 1 up top times 3x times x minus 6. And in the denominator, I have an x. I have an x plus 9 and a 6 minus x. Now what can we simplify here? I can definitely see that we have an x that can reduce to 1, and be on the lookout for this type of thing. X minus 6 and 6 minus x, they are opposites of each other. So when I reduce that, I'll have a negative 1, and that looks like all we can do here. So what we have left is a negative 3 in the numerator, and in the denominator we have an x plus 9. Now, what is the valid domain? We have to go back and look at what would create zeros once we're in the multiplication format. So that's the row we want to be looking at. So we can see that x absolutely cannot equal 0. That would cause a 0 in the denominator. By the way, I should point out this here too, either one of those rows. We can see that x cannot equal negative 9, and x cannot equal positive 6. And I think it's worth pointing out here that a common student misconception would look at what would create zeros here with this expression, 3x squared minus 18x. That's actually really in the numerator, so don't fall for that. Just a caution there, because I've seen many students do that in the past. All right, for a second example, we have two expressions, 2x squared minus 12x over x plus 5, being divided by x minus 6 over x plus 5. So that first one, I'm going to go ahead and pull out a 2x in the numerator, and that would give me x minus 6 left, and I've got an x plus 5 on the denominator. Well, I guess we can probably go ahead and turn this into multiplication at this point, since I don't have any simplification to do. So I'm going to turn that division into multiplication, and now I'm going to take my reciprocal. So the x plus 5 goes on the numerator, the x minus 6 is in the denominator, and now we can start doing our multiplication all across. So in the numerator I have 2x times x minus 6 times x plus 5, and in the denominator I have x plus 5 times x minus 6, and we could see that our x plus 5 reduced to 1, our x minus 6 reduced to 1, and this big complicated quotient of rational expressions reduces all the way down to 2x. So what rows are we looking at to determine our valid domain, either here or here? So we can see that we would have to exclude x equals negative 5, and we have to exclude x equals positive 6. All right, so in this video we looked at rational numbers and finding the quotient of those, talked about some misconceptions. Then we applied the same concept to finding the quotient of rational expressions. Hope this video helps. Thanks for listening.